This video will be a general introduction in English to the Tomix N-Scale Automatic Operation System known as TNOS, or TNOS as they say in Japan. Before I get into the description of the basic TNOS control unit, I want to go over some fundamentals of the Tomix layout wiring system and the basic manual control system, and then we'll get into the first generation of Tomix automatic operation, which was known as the 5563 automatic operation unit. Let's begin with the basic control system. This is the Tomix N1000CL power unit, which is what they call power packs in their nomenclature. The N is for N-scale, the 1000 is the model number. The current model number is 1001, which is virtually the same as this. This is the basic workhorse unit in their line of controllers. And the CL means constant lighting, which we'll explain. The Tomix systems use a basic parallel two-prong plug. It's non-polarized, so the plug pins are the same width. Unlike the modern polarized in the US, they fit fine in American receptacles. In Japan, they use 100 volts. In the US, it's 120. And in Europe, they can go up to 240. The modern power packs can handle any of those voltages, 100 volts AC to 240 volts AC, 50 to 60 hertz, all built into their power supply voltage reduction units. The basic setup features an on-off switch, a direction switch for polarity, and a throttle which goes from off to maximum. The CL feature is for constant lighting, and what that means is you can set a lowest voltage used so that the lights stay on but the train does not yet move. The way they do that, all modern Tomix power packs are pulse width modulated, or PWM. They use electronic circuitry. They don't provide a steady voltage that goes up and down from 0 to 12. They provide a steady 12 volts, but they vary the width of the pulse from 0 basically to 100% of the time until the next pulse. So a very narrow pulse down near 0, even though it's 12 volts high, provides an average voltage of 0, whereas a full 100% width pulse provides full average voltage of 12 volts. It may sound unusual, but it's the same way that most modern power packs work, and it's also the way that DCC or digital control chips that you mount inside a train break up the voltage to power the train. So it's something that's very common in the industry now. The way it works on these packs is there's a router turquoise dial, which you can set up or down to where especially if you're bringing a train to a stop, where the train actually does come to a stop, but the lights stay on. Once you've done that and set it to where you want, that sets an artificial lower bound for how far you can turn this dial down. And as you can see by the line, it stops there. So that when I stop the train, there's still enough average voltage for the lights to light on the train. Tomix, like Kato, uses a snap-on system for accessories and particularly switch control. This is a switch control unit. It's a momentary contact. The switches are DC, and it just snaps into the side, and you can keep snapping them on as many as you want. The way the switches work is by DC. They do not work by AC. The Tomix accessory power is called TCS Power, and it's 12 volts DC. So the switches are only 2-wire controlled instead of 3-wire, which you may be used to in the United States. And it throws the switch based on the polarity of the voltage. I can show you something simple here, and that is that these switches have the switch machine mounted underneath, and it snaps right out. And you can see the two coils and the wiring and the cabling. A manual switch is exactly the same, except this piece has no cable attached and no magnet wires wrapped around the armatures. So you can convert a manual switch to an electric switch very simply, and it all just fits underneath. You can throw it manually no matter which type it is, and what slides back and forth has a magnet on it, so even the unpowered ones, the magnet is up against one metal armature core or the other for the coils. That tends to hold the switch in position, and the switch can be used as a sprung switch if you're merging in. So it's a very flexible system. The entire cabling system of this uses what is called the NEO, that's the present version cabling, and you'll see that logo identifying everything that's NEO. Tomix offers no terminal tracks. They offer this. This is the classic DC feeder, and this can go into any curve or straight of the normal track type from 70 meters or 103 millimeter radius or 70 meters straight up to longer sizes and larger radii. It simply goes in, one prong makes electrical contact with the bottom of each rail. You can do it from either side on two recessed areas between ties or sleepers on each piece of track. So they're very flexible in terms of where you want to put your power feed. There's one on a straight track. The other end simply cables in to the power pack, the power unit. And they're all color coded, and also the connectors are different sizes and shapes so that they can't be miscabled. The black unit is the TCS output, that's 12 volt DC power for accessories and switch control. That also comes out here when you put these on, and the connection is made automatically. And that's basically it. The power comes in, train power comes out, TCS power comes out. Everything is done with cabling under the NEO system. So you don't need a screwdriver, you don't need to take the insulation off the ends of wires or do any soldering or anything like that. It's a very basic and plug and play system. What I'd like to cover next is the first automation system that Tomix produced. It was the 5563 TCS Automatic Operation Unit. And here it is. It fits compatibly with their basic controllers, and what it does is it intercepts the track going out to the power to the track, and it routes through this system instead, and then this system has its own output to the track. So this gets lined up between the power unit and the track. This provides the TCS 12 volt power to power this unit, and the automatic operation unit has within it, hardwired, 9 different layout and operation sequences pre-programmed. You can turn the dial to select which operating layout and sequence you want, 1 through 9. They're all detailed in the Tomix 5563 operation manual, and you can see the different layout configurations in basic form here, and then as you go back in the manual, they show specifically exactly how to run it and exactly how to wire and cable each of the layouts. So you can select which mode you're using for automation. The second dial here, you can select the acceleration deceleration rate. It's like momentum. The higher the dial, the more momentum the train seems to have, the slower it accelerates and the slower it decelerates, and the more distance it takes to do so. You can also adjust this dial, which goes from a minimum to maximum setting, for the amount of delay that a train will stay stopped. During an automation, the train may stop or even stop and then reverse, and you can pick how long it stops by setting this dial as you wish. Once you plug this to here, you set a polarity and a maximum running speed, and then this takes over and it runs the layout in the sequence and repeats that sequence endlessly until you stop it. There's a 10th setting on this dial, which is simply a through setting, and you can bypass all of the automation and simply run the train manually if you happen to have this already wired in case you want to warm up a train or test it or something like that. That is the TCS automatic operation unit. The interesting thing about this, if you look at it in terms of logic, it has one output to the track. It has two outputs to control turnouts or switches or points, as they call them in Japan and some of the rest of the world. And it has four inputs for sensors, which detect a metal flange passing by, grounding the detector piece to the rail as it passes. And those sensors initiate actions and sequences, then they run through in a programmed way. So it's got very limited input, only four sensors. It can control only two turnouts or points, P1 and P2, and it has one basic output. It sets the voltage for the whole layout that you assemble. The layout is simply one block. That's the basic of this. The settings are all described in the manual. You have to wire things and organize the switches, the points, and set the sensors as described, and the program will follow those particular layouts. We'll see how this compares to the Tomix TNOS, the new unit for automation. Just remember, four input sensors, one output for the track, two outputs for points. That's what you're limited to. So the basic limitation is you can only run one train at a time because you are accelerating and deaccelerating and starting and stopping and reversing the entire layout. It's one block. That's how this system works. You can do a lot with it, and there are lots of ways that people have found, one of which I put on the internet on YouTube, to kind of massage or manipulate the track diagram to have it act in a different way and actually look totally differently, and yet still follow the pre-programmed sequence that's built into this box. With that as background information, let's look at the new Tomix TNOS automatic operation unit. The TNOS system, unlike the earlier automatic operation unit, is a fully computerized, software-run control system. The programs are not hardwired. The layout designs and multiple operating sequences for each layout are contained on this SD memory card. This card is inserted into the control unit before it's turned on. The control unit runs off a wall adapter. The wall adapter again can handle 100 volts to 240 volts, 50 to 60 hertz, pretty much usable worldwide, as is without converters. This plugs into the back of the control unit to give it power. The control unit has a numerical display. It has several indicator lights, LEDs across the top. It has an on-off switch with a power indicator. It'll indicate green if there's power, and it'll go red if there's a problem detected, such as a short circuit, and the power gets shut off immediately. It has a dial for selecting numbers, numerical choices, and it has a keypad for selecting various operations used to control it. That's how it works. And when you turn it on, it says TNOS. The difference between this system and the other, aside from not being hardwired, is that the operations are much more flexible. This cable coming off is a network cable of sorts. It has a 3-wire network cabling system that plugs from the control unit over to an ND hub, which is an input-output power hub. This hub, compared to the 5563 automatic operation unit, has 8 sensor inputs across the back instead of the 4. It controls up to 4 blocks of track, and it controls up to 4 points or turnouts. It has its own power supply, which is exactly the same as the one that powers this from your commercial power. And it also has something you should be very careful with, and that is a small terminating resistor, which you don't want to lose. That goes in here and terminates the end of the network cabling. This is even more flexible than that because you can add multiple ND hubs. The current manual, which is 45 pages long and details all the operations and settings and layouts, indicates up to 4 of these hubs. Here's a hub with the ports for the communications cable, the network cable, the terminating resistor, input for power, TCS 12 volt DC output, an on-off switch of its own, and some other network cable power connections that are not yet used. These are the sensor inputs 1 through 8, and this is the track feeder outputs and the points or turnout outputs. I should point out that these are removable. They're essentially little bricks that come right out. As far as I know, they cannot be interchanged. You cannot put feeder track bricks into these openings. Even if you could, which might save some money because we tend to need more blocks than points for control, the programs would have to be reprogrammed to address the right locations for relocated feeders. Tomix is already selling these as replacement parts, but they kind of go where they go now. And again, you can have up to 4 of these, so you can eventually get up to 4 times this, 32 input sensors, 16 blocks of contract power, and 16 points that can be thrown. These can be fastened down using these holes, so if you want it on the side of a table, you could do that. They have little nibs and recessed areas, so you can even stack them up if you want to. Generally, they tend to get spread out along the layout so that the cables can reach to the various points and track feeders. But this is the ND unit. This is the control unit. The control unit, you can see the display here. It has the LEDs. It has a green signal LED. If you're watching a particular train on the display, it tells you which signal that train has, whether it can run at full speed under a green signal condition, at a reduced speed on a yellow signal, or whether it's got a red signal and has to come to a stop. While it's decelerating, another red LED comes on, sort of a braking light. There's a 5th LED here, which is yellow, and that indicates when you've taken over control of one train to manually operate the speed, which this system allows you to do. It has a number of inputs here. They're not all ones you need to use right away. We'll get through those in the operation of various layouts. And it even has an adjustable opening here along the back that you can put a smartphone into. If you have their onboard camera car train, you can put your phone here and watch the view from the cab as you motor around. I wouldn't doubt that they have other anticipated uses for connecting this to smartphones. That's the basic TNOS system. When you use it, obviously you need to put in gaps between the sections of track that are being separately powered. You need to feed each track separately, and there's a numbering system. F is feeder, 1 is TN hub number 1, and this is feeder number 1, the port for that feeder. This is the same box, port number 2, and so on. These are the sensors. Sensor box 1, number 1, box 1, number 2. The blocks I've numbered here, and I've used the same color coding that Tomix uses in some of their demonstration layouts in Japan, and in this document, which provides a background for the 10 different layouts that are programmed already by Tomix, and each of these 10 layouts has multiple operating sequences that can be handled automatically. Quite a complicated system. At this point, there doesn't seem to be any way to design your own layout, program it in, and program in the automation of it. It's all done at this point at the factory. They have promised to introduce additional layouts and additional operating sequences for those layouts, and they can do that because everything comes on a SD memory card. It has a lock to prevent accidental erasure, and they can at any time they want issue new memory cards or even updates online to add additional layouts and operating sequences into the logic for this programmable unit. I want to demonstrate very simply the basic operation of the TNOS system. To do that, I'm going to use layout plan number 1, which is a 3-block oval with the 4th block being a passing siding. Also, I'm going to use an operation mode for automatic operation. That is what they call a trial operation. It uses only one train and sends that train all around to every block, throws every point or turnout, and checks the operation of every sensor so that you know the layout is correctly configured and all its components are working right before you get into more complicated operating modes with multiple trains. The TNOS system, when you turn it on, starts up with TNOS. This box is also turned on. The card must be in memory card before the power is put on, and I just leave it there unless I'm putting the box away for storage. The train must be where it's supposed to be in the sequence, and the sequence is described either in this document, which uses the same color coding as the pieces of paper I put around to identify everything, or in the larger TNOS manual. I think I said earlier this manual is 45 pages. It's actually 38 pages plus the cover and the back. With this basic set that I received, I also got a correction or errata sheet, which shows some of the diagrams and the corrected version of them. If you get one of these, you may want to check it for any layout you're putting together like this one to make sure that you have made the corrections that they have discovered need fixing in their manual. The operation is very simple. When you get everything running well, it actually looks very regular and organized and smooth, but in point of fact, many things are going on behind the scenes to make that happen. You can make trains of multiple manufacturers all run compatibly together, no matter what their operating characteristics, and have perfect automated operation without the need for putting any decoder chips or anything else into your trains. Okay, to start out the TNOS system, the first thing I'm going to do is select a layout plan. This is layout plan number 1. I push the keypad button, which looks like a layout diagram in the upper left, and it has an L for layout, and I can turn the dial to select whatever layout I want. The dial just spins, by the way. It does not have a max or an off setting. It just goes around and around and around. So I pick layout number 1. I hit the check mark button on the keypad, which is a confirm or enter button. And a decimal point shows up behind the 1, indicating that that is now locked in and confirmed. The next thing I need to set, now that I've selected a layout, is which automatic operating sequence for that layout I want to use. That's the button below, down here, the second one down on the left, which looks like a string chart. If you know what a string chart is, it's what they use in railroad scheduling from earlier days to show the sequence of trains moving down the line vertically with time going horizontally. So I select that. A pops up for automation mode. I can then turn the dial to pick the mode I want. Number 4 mode for layout number 1 is the trial operation mode with the one train that I've explained already. So I select number 4, I confirm it. I have to do a third thing now, which you might not have to do if you're just running Tomix or Kato trains, and that is I am running an Arnold tram, which has different speed characteristics at different voltages than the Japanese typical train. So what I need to do is to set a train number. I want to select train number 1. There is only one train in this mode of operation. I put the decimal point behind that. And then I select a parameter set for this. I have custom set and stored in here various parameter sets for different manufacturers and types of model trolleys. In this case, I use my parameter set number 3 for these Arnold trams. So I'd set the dial to 3, I hit the confirm button, and then I'm ready to go. The trolley's in the right block. I have set the layout, the automation, and even tailored the voltages and the deceleration rates to this particular brand and type of car. I then hit the go button, which looks like the play button on a video. It's an enter or a go or a confirm, or I'm sorry, it's a go or resume button. And you'll see the speed start up. It's under green signal conditions. It goes up to a speed level of 50. Level doesn't mean anything. It's not miles per hour or kilometers per hour. It's simply a numerical number. A reasonable speed for these trolleys from Arnold I've determined to be about 50 on this dial. The train will go around. The switch will throw automatically to route the train into the passing siding so that it can test out that particular section of track. The train will continue around the loop again. When it gets to the far left sensor, it will get a yellow block because it's going to stop again when it gets here. And you'll see the speed reduce. This is, we're monitoring train number 1. It's going at a green signal speed of 50. It will drop down to 40 using my designated deceleration rate, at which time the braking light will come on. There it is going down. The braking light is on, and now it's operating at yellow signal speed. When it gets to this sensor, it will slow down rapidly to off because it's getting a red signal at that point. The deceleration light is on. It's down to 0. The cycle is done, and it goes back to the TNOS display. That's it in a nutshell. That's how the operating modes work. And if I want to run that again, it's all set already. All I need to do is press the start button, and away it goes. There are also ways you can have it resume that cycle for a designated amount of time using the button that looks like a clock, or for a number of repetitions of the cycle using the circular arrow with the 1, 2, 3, the repetitions button. All of these buttons do various things. Some are more useful than others. You really only need, in my case, 5 to set up and run the layout, and I can continue to run it as much as I want. And once I know it's working, I can go to more complicated operating modes and run multiple trains at once.